Algebra word problems number 36b. Write, solve equations for mixtures, two variables. We're going to solve for x and y. Making a table is the easiest way to solve mixture problems. A solution mixture problem deals with percentages of chemicals which are mixed together to create a mixture. It's useful in chemistry, and they use the term solution, concentration, which means strength, and they may refer to the concentration as a percent solution. It's the main ingredient. So think of making sweet tea. We add 4 cups of water and some tea and some sugar and mix them together. We made a solution. And we've solved mixture problems for one variable in my previous videos, and now we're going to use more than one variable and a system of equations. So now here's our new equation, our new word problem, How many gallons each of 25% alcohol and 35% alcohol should be mixed to get 20 gallons of 32% alcohol? So think, 25% alcohol is 75% of something else. So it's kind of a weaker solution than the 35% alcohol, isn't it? So it's only, a little bit of alcohol compared to this one. And this one is not 100% either, but it's still stronger than the 25%. And we need to find a 32% combined solution mixture and 20 gallons of it. So the 32% one is going to be stronger than this one, but weaker than that one, right? Not quite in the middle. It's closer to the 35. It's just a few percentages weaker than the 35, isn't it? So here's our bottles. We've got 25% alcohol, but we don't know how many gallons. We know that the total is going to be 20 gallons, so we're going to let X equal the gallons of 25%. Here's our 35% alcohol, and we don't know the gallons. It's Y gallons, because we don't know what it is. We just know that if we add this one to this one, see we're adding, that it's going to equal the 20 gallons, okay? So now let's plug our information into our table. And if you remember from the previous video, I don't make my table like other teachers do. I use a method that I invented called the PQP table. And it's the percent, the quantity, and the pure. So in the first line, we're going to put the percent of the solution that they gave us, the 25, 35, and 32. In the second line, that's our quantity, that's our Q. In this case, it's gallons. Well, in the last video, it was ounces. And that's why it's the quantity, because it always changes. So we've got our percent, now we're going to do our quantity. Well, we don't know how many gallons of the 25% we're going to have, and we don't know how many gallons of the 35% we're going to have, but we do know that the 32 is going to be 20 gallons, okay? Then our final line here is the pure. That's the PQP. And it's going to be the gallons of pure. Now, the way to get this line, this one was easy because it was given to us in the word problem, and this is what we assigned as the variables to equal the 20 gallons. That's our first equation. But to get our second equation, what we're going to do is we're going to multiply straight down in each column, the 3 columns, and that is going to fill in the equation, your second equation, by multiplying straight down on these. So watch. 25 times x is 25x, but because it's a percentage, we write it as a decimal as 0.25, so we have 0.25x. 35 times y is 35y, but because it's a percentage, we write 0.35, and now we've got 0.35y. 32% times 20 is 32 times 20, but because it's a percentage, we write 0.32 times 20. And now this is our first equation, and that's our second equation going straight across. The quantity gives us our first equation, and the pure row down here gives us our second equation, and we got it by multiplying down, and multiplying down. See? So now we've got our 2 equations. Let's see what we can do with them. This is equation 1, and this is equation 2. So the first thing we've got to do is remove this parentheses from equation 2, and we do it by multiplying these 2 together, 0.32 times 20. And what we do when we multiply 0.32 times 20 is, remember there's 2 hops over for the decimal point in the equation, so there's 2 hops over in the answer, we end up with 6.4, okay? So now we've got 6.4 as the answer after the equal sign, and we need to eliminate the decimals in equation 2. We need to get rid of these decimal places. So what we're going to do is we're going to multiply each side of the equal sign by 100. See? So remember, the equation is like a scale, and we need to keep it balanced. So whatever we do to one side, we have to do to the other. And because all of them have these decimal points anyway, even if this didn't have a decimal point, to get rid of these, we would still multiply it by 100, and that would just get zeros added to it. So now what happens, because we're multiplying it by 100, instead of in front of the 2, now the decimal point is behind it. And now instead of in front of the 3, the decimal point is behind it. And now, because instead of the decimal point being in between the 6 and 4, it's after the 4, and then one more, we have to add a 0 here. So it's 640. So now this is our new equation number 2. All right? So this was equation number 1. We need to plan ahead. I noticed that equation number 2 has 25x here. So because equation number 2 has a 25x there, we're going to multiply both sides of the equal sign in equation 1. Okay? Because equation 2 has a 25x there. Equation 2. We're going to multiply both sides of the equal sign in equation 1 by a negative 25. This is planning ahead, okay? Can you imagine what's going to happen if I multiply this by negative 25? I'll get a negative 25x that when it's put underneath this, it'll get x by itself, won't it? All right, so we multiply both sides of this equation by the negative 25. We multiply this side and we multiply this side by the negative 25, and it becomes negative 25x plus a negative 25y equals 500. Okay? Actually, it's a negative 500. Okay? So, now this is our new equation 1. That's our new equation 1. Okay? And we're going to subtract equation 1 from equation 2. And we do. And this ends up falling off. If we have a plus 25 and we take away a negative 25, then it's gone, isn't it? We've just eliminated it. So now we just have 35y minus 25y, and that gives us 10y, and 640 minus 500 is 140. So we're going to use the inverse operation of multiplication to divide both sides by by 10, and we divide this side by 10 and that side by 10, and what ends up happening is 10 over 10 is 1. When the numerator and denominator are the same, it equals 1, doesn't it? So now we have y by itself on this side, and 140 divided by 10 is 14. So now we have y equals 14. So now we can plug y equals 14 into equation 1, into the original equation 1, okay? Remember the original equation 1 was x plus y equals 20? So now we're going to plug the y equals 14 into that equation, and look what happens. This creates a 0 pair, right? So it's gone, and 20 take away 14 is 6, x equals 6. So now we know that y equals 14 and x equals 6. So now we know what goes here. Y is going to be 14 gallons, and x is going to be 6 gallons. And now we know the solution for the solution, don't we? We know the answer to the mixture problem. All right, so I'm going to make a couple more of these that are like offered in different ways. So hopefully these are going to help you, and I'll see you next video. Bye.